For the first section, you do need to know your number sets. So remember, we have the set of real numbers, and then from there, we have rational and irrational numbers. And then we have our set of integers, our whole numbers, and our natural numbers. And so natural numbers are just your one, two, three. Whole numbers includes zero. Integers includes your negative, and rational includes your fractions. Irrational, remember those are radicals that cannot be reduced, something like pi, non-repeating, non-terminating decimals. So if it wants you to name the set of numbers that this belongs to, you're going to start with the lowest one, which is integers here. And so this is integer, this is rational, and this is real. To order of operations. So for order of operations, obviously, we're familiar with the PEMDAS. Remember, the P can stand for parentheses, but any grouping here. Then we have exponents, multiplication and division. Remember from left to right, doesn't matter which one comes first. Addition and subtraction again from left to right. And, you're going to have your basics with just integers here. For fractions, remember for adding and subtracting, you need a common denominator. For multiplication, you just multiply across. And for division, you're going to keep, change, and flip. And so you will use order of operations for something like 2 and 3, as well as 4 and 5. Evaluate just means plug these numbers in and then use your order of operations. From there, we move to simplifying exponents. And so as we look at exponents, we're going to have to remember our rules. When we multiply like bases, we add those exponents. When we divide like bases, we subtract those exponents. When we have some power to a power, we multiply. And then our specialties, when it's a zero, it's just the number one. When it's a negative exponent, it puts it in the reciprocal position. And so as you work through these, you want to group like things. So group your numbers, group your like variables, so that as you go through these, you can apply those rules. This is adding my like, so I'm going to say 4 plus 4 plus 4, adding 0 plus, remember that's a 1 plus 2. And once you get it to one number and one of each variable, you are done. And so as we apply these, we're going to say one piece at a time as we do this. You just want to take it a piece at a time so that you can work through it. Remember, when it's numeric, you want to go ahead and do that. So we have 8 times 2. Go ahead and do the multiplication of those, the multiplication of those. And again, we're just putting like pieces together. So we've already multiplied our numbers. When I put these together, I add 6 and 4. When I put these together, I add 12 and 2. And when you get to one number and one of each variable, you are done. For fractions, you want to simplify the numerators and denominators individually. So like we have 3 times 3, we're going to simplify that. X to the negative 3 plus that negative 4, so x to the negative 7. And then we have that y. And now that they're simplified as much as they can individually, we're going to go top to bottom here. So I look at that 3 over 9. Can I reduce it? Yes, that's 1/3. I look at the x's. I'm going to do that subtraction. Negative 4 minus a negative 7. Well, negative 4 minus a negative 7 is positive 3. So I have an x cubed up here. For my y, I have 0 minus 3. Well, that is negative 3. So I have a y cubed down here. And so just one piece at a time for those. When we are simplifying, we are looking to, again, combine our like pieces. I'm going to take that 3. I have a minus, and I'm going to find the number that goes along with it, negative 4. Then I have a 6p squared. Again, it is a minus, and I'm doing a p squared. Then I have a negative 8p to the fourth with that minus, and a 5p to the fourth. 3 minus a negative 4 is 7. 6 minus 1 is 5. And then negative 8 minus 5 is negative 13. And remember, standard form does highest exponent to lowest exponent, and then to our constant. One, 4, and 1, 6 really dealt with simplifying equations, and basic inequalities. And so for basic equations, you want to do your distribution first, and then you want to combine anything that is on the same side of that equation. So in this case, these are on the same side. So we're just going to do what it says, negative 5 and 30. And then once we've simplified each side, we are ready to move our numbers to one side and our variables to the other. And once we have our numbers on one side and our variables on the other, we will finish with division here. For fractions, remember you can get rid of those denominators by finding your common denominator between all three of them. In this case, your common denominator is 12. So I can multiply each piece. Remember, as long as you multiply every piece, you haven't changed it, and then you're going to cancel. Whatever cancels, 12 cancels with 12, I'm left with 5. 3 cancels with 12, I'm left with 4 times negative 5x. And then 4 cancels with 12, I'm left with 3 times 5x. And we just have a basic equation to solve here. Remember, combine any like terms that are on the same side there. And then our last step is, of course, to divide. For decimals, we do have a shortcut there, or you can just add and subtract your decimals, but you can move those across, and you can, again, solve these the same way here. So as you work through these different ones, um, you're still doing the same process. You're going to combine like terms, you're going to divide, and then you're going to simplify. For inequalities, really, the main difference here is to watch out for your negatives. And so inequalities, again, we're going to distribute here. We are going to move our numbers to one side and our variables to the other. So for this one, my final step's to divide by negative 7. And when you divide by a negative, that's when you're going to flip that sign. So 35 divided by negative 7 is negative 5, but I am going to change this sign. I'm going to flip it the other direction. And when you're graphing, you are always graphing the variables. So as I look at this, I'm going to say x is bigger than negative 5. So I'm going to go to negative 5. I'm going to do an open circle there because it's just the greater than, less than, it's not the or equal to, and then I'm going to graph the side that is bigger because I'm always graphing my variable. When you have variables on both sides like you do here, you just want to move those variables to one side. So I'll move that 5r over, and I'm going to move my numbers to the other side. Here, however, I am not dividing by a negative. I know that 48 is negative, but we're only looking at the number that is with the variable. So in this case, it does not flip. I'm going to go to that -3. It is an or equal to, so I'm going to do a closed circle. And again, my variable is bigger than the number. And it doesn't really matter how large they get. I'm going to do my distribution. I'm going to combine my like terms, and I'm going to divide at the end. For section 5, we had 3 different types of word problems. Remember, consecutive integer. In this case, we have 3 of them. You don't know the first one. The second one's going to be +1. The third one's going to be +2. If they had used the term even or odd, then those are always 2 apart. Even and odd are both 2 apart. In this case, just consecutive. They said the sum, so sum means add them up. And they can tell you add them up, or they can tell you do something else with them. But either way, you need to just follow it to set up that equation. And then again, we're just doing basic solving here. So we can take what we have here, we're going to subtract that 3 over, and then we're going to divide by 3. So we have x equals 41. It did ask for all 3 of them, so you want to make sure you do the next 2 integers there. We also did angles, and so remember, supplementary means they add up to 180. Complementary means they add up to 90. So we have supplementary angles. We do not know the first one, but it says that the larger angle is 24 more than twice the smaller. So if we don't know the smaller, we're going to say twice the smaller plus 24. We're just going to say the smaller. Well, that is just going to be our x. And to find the measure, we're going to add those. And so again, it's complementary, so it's 180. We're going to do the same thing we've been doing to solve these equations. We're going to combine our like terms, subtract that 24 over, and then divide by that 3. Now remember, these are supplementary, so they should add up to 180. So once I know one, I'm just going to take 180 minus that one, and I will get my second angle here. So those are my 2 angles. The last type of word problem we did was ratios. A recipe for trail mix calls for raisins and peanuts in a ratio of 3 to 4. If you want to make 28 cups, how many cups of each will you have? So you're going to set these up with your variables. 3 times some number plus 4 times some number equals that 28 cups. And so the first thing you want to do is find out what the x is. Well, the x is 4. To figure out how much you need of each, you plug it back in. 3 times 4 will give you 12 cups of raisins. 4 times 4 will give you 16 cups of peanuts. And the last section dealt with compound inequalities and absolute value functions. For compound inequalities, you're just going to do what we did before. You're going to solve these inequalities individually. And for or problems, you're just going to graph what it gives you. So you're going to subtract that 6, divide by the 3, subtract the 6, divide by the 3. And then you're just going to graph it. K is larger than 3, so open circle, larger. K is smaller than -1, open circle, and smaller. But for your and problems, you are really answering where do they cross. And so as we do this and problem again, we're going to do it individually, just like we've been solving it. And so we're moving our variables to one side, we're moving our numbers to the other and dividing. Same thing with this one. So we have a is less than 6, goes this direction, and greater than or equal to 5, which goes this direction. And so when I put that on the graph, I only include the part where they overlap. And so that's what that is going to look like. For absolute value, you want to get the absolute value by itself first. So move anything out of the way. And then set up two equations. Just exactly what is inside equals what's on the outside, and exactly what is inside equals the opposite or the negative. Solve, you're going to get two answers here. So we're going to solve exactly the same way. You're going to get two answers. For something like this, again, move that 5 over first, divide by that -2, and then set up two equations. And you're going to solve that. Again, this last one is really the same. You just need to check your answers. The absolute value is already by itself, so you can go ahead and set it up exactly the way that it gave you. Uh, and then you want to set up the opposite. In this case, you need to put the negative out there. When you solve these, you do have to check for extraneous solutions. So when I move this over, I'm going to get x equals 6. When I distribute here and then move these over, I'm going to get x equals 2, and I need to plug those back in. So 6 and 2 are what I'm seeing. If I plug in a 6, 6 plus 2 equals 3 times 6 minus 10, so I get the absolute value of 8 equals 8. If I plug in a 2, I get 2 plus 2 equals 3 times 2 minus 10. I get the absolute value of 4 equals -4. That is not true. And so this is extraneous, and this is my only solution.